Alright guys, we're going to look at curve fitting with linear models in this video. Curve fitting or linear models is when you have correlation and you have a scatter plot. Now scatter plot is when you plot points and you can find a relationship between two different variables. In this case it's going to be the x values versus the y values. And correlation, it tells us the direction of the relationship, and correlation coefficient also tells us the strength of the relationship. Now for the type of scatter plots, we can see the correlation that it has. So the first scatter plot that you see here is when you have positive correlation. So you have some points and it has positive correlation because if you draw a line trying to connect the points, it has a positive slope. It's going uphill from left to right. The negative correlation is when you have a line going downhill from left to right, so negative correlation. And no correlation is when the points are scattered around. You cannot make a line when you connect them, so there's no relationship between two variables. Okay, so we can find the correlation coefficient to find the strength. And when you have a positive correlation, positive slope, you have and it makes a really good line, you can say you have a strong correlation. And negative, or same thing, is going to be a negative correlation, and if you have a line, it can be strong. So let's look at how to find the line that best fits the data so we can predict the outcomes. Now remember that you can connect the points, try to connect the points and make a line, but we need to find the line that best fits the data. So let's go ahead and look at it. So you guys can see a piece of table here, which is data, your data. The table is your data. You have the x values, you have the y values. Sometimes the values or the variables, the x variable and the y variable, they do have a name. X can be time, y can be height, x can be miles, y can be I don't know, it can be speed. So it just depends what they give you guys, but it can have names. First of all, you need to understand what the correlation coefficient means. So let's look at up here. It says a line of best fit can be used to predict data, and we can use the correlation coefficient R to measure how well the data fits. First of all, R is between -1 and 0, so that's the value. As R gets close to -1 or +1, that means you have strong correlation. And if it's negative, doesn't mean that has to be bad. If it's positive, doesn't have to be mean that it's good. It just depends, right? But when R is near -1, you have negative slope. When R is near +1, you have positive slope. And if R is near 0, there's no correlation. You guys can see the scatter plot of the data. So you just plot the points, 1, 16, 1 to the right, 16 up, 2 to the right, 14 up, and so forth. The points are really close to each other. So that means that there is strong correlation. We don't know how strong it is just by looking at the scatter plot. But when you use your calculator to find the R coefficient, we can say how strong the correlation is. So we're going to use the linear regression from the stats calculator. And you guys can see that I already have the data or the information over here. So we do have the equation of the line of regression, y equals a plus bx. We have the a value, we have the b value. A is your y-intercept, b is your slope of the line. R squared, we didn't talk about that in class, don't worry about it, but you jump to the R, which is -0.96. Now this is very important. Correlation coefficient -0.96. The number -0.96 is really close to -1, so it means you have strong correlation, really strong correlation. The points are really close to each other, and you can see that on the scatter plot. To find the equation, the best fits the data, you're just going to substitute the values that you already have. You already have the A, you already have the B, and you substitute it into the equation. Now remember, I told you guys to use y hat. That means predicted value. So I have 17.79 minus 2.20 x. Right? Using this equation right here, you guys can start predicting outcomes. So notice that the x values in the table, they go all the way up to 8, x equals 8. But if you want to know what the y value might be at 9 or 10 or 11 or 12 or whatever number you want, you can substitute that number into the x, and it's going to give you an outcome. It's going to give you y hat. Y hat is a prediction. Keep that in mind. Doesn't have to be that number, but it can be the actual value can be close to our y hat value or predicted value. It can be a little bit more, it can be less, but it's just a prediction. Now, sometimes looking at the scatter plot, it might look linear, but it can be quadratic, it can be cubic. Remember, there's different functions out there. It can be a square root function, it can be logarithm function. There's many functions out there. So what we can use to check if a linear model is good to use in a piece of data, we can make a residual table and a residual plot to check. So let's go ahead and look at the residual. So first you need to know the residual, how to find residuals. So residuals is going to be the actual y value minus the predicted value, y minus y hat. Not the y, the actual value, are the y values from your table. So here's 1y, 14 is the second one, here's a third, and the last one. So those are the actual values. Our predicted value, y hat, is when you substitute the x into the value of x into the equation and you find y. Those are the predicted values. Alright? So you get these numbers from the table, you get these numbers from the equation we found, the line that best fits the data. I already have kind of what the table looks like, and I'm just going to tell you how to get the numbers. So first of all, to get the predicted value, notice the first predicted value is 15.9. All I did, guys, I took the first x value right here and I substitute into the x. Whatever I got, I use the calculator, I simplified, and I got 15.9. Then I took the second x value and I substitute into the x, and I got the second predicted value. So you substitute, simplify, and that's how you get it. Then you substitute the next one into the x, and I got 11.7, and finally you substitute a 4 and I got 9.6. Now this is how you get the residuals. To get the residuals, you are going to graph the first actual value, 16. So I'm going to put 16 here, minus the predicted value. And the first predicted value is 15.9, which is right here. So the actual minus predicted, and that's going to be 0.1. Now the next one, you substitute, I'm sorry, you don't substitute, you get the next, so let me erase this here. You get the next y value, so 14, so I'm going to put here 14 minus, and then you get the next predicted value, which is 13.8, 13.8. And 14 minus 13.8, that's going to be 0.2. 0.2, right? So this equals 0.2, this equals 0.1. And the next one, you get the next y value, which is 11, sorry. So you get this number here, 11, minus 11.7, and that's going to be negative 0.7. Then you get the last y value in the table. So we have 10 minus 9.6, and that's going to equal 0.4. So that's how you get the residuals. We find the predicted value first, and then we subtract the actual minus the predicted one. Now to make the residual plot, we use the residual table that we just got, and we make another scatter plot. But in this case, the scatter plot is going to be the X values versus the residuals, not the Y values. The X values on the previous slide were 1 through 4. X equals 1, 2, 3, and 4. So you're going to make your Y axis here in the middle for the residual plot. You're going to have the X axis. So here's my X. Origin is right here. Remember that the X values we had were 1, 2, 3, and 4. And you're going to start plotting. So my first X is 1. My first residual is 0.1. So 1 to the right, 0.1 up. And it's not going to be perfect, but you guys are going to approximate. So next one is X2, and the residual is 0.2. So more or less right here. Next one is X3, negative 0.7, which is somewhere over here. And the last one is X4, and then 0.4 up. Now this is what we look for in a residual plot. If you want to know if a linear model is a good model to use in a piece of data, you need to look at the residual plot and check if you have half of the points on top of the x-axis, on top, and half of the points on the bottom. That's the first thing you check. The second thing you check is if you do not have patterns. If you connect the points, you don't want to make an S shape or a line shape or a U shape or some type of shape, MW shape. You don't want any patterns. You just want the points to be scattered all around. But the third thing you need to check is the points have to be close to the x-axis, not far away, way up here or way down here. They have to be close the x-axis. So those are the three things you check. You want to check that there's half and half. You want to check that there's no pattern. They're all over the place. And you want the points close to the x-axis. Now on this one, if you look at this residual plot, we have 3 points on the top, 1 point on the bottom. That's not half and half. So you can say a linear model is not good to use. But for the data that I use, remember the x values were 1 through 4. Those are too few points to actually say if a linear model is a good model to use. The more points you have, the better idea you will have. But remember to look for the three things in a residual plot.